Hello everyone and welcome to We Are Learners. So recently I had a question. Sir, if 1 to the power 0 is 1, as we know that anything raised to power 0 is 1, right? Except 0 to the power 0. And 1 to the power 1 is also 1. So from both this, we can say that 1 to the power 0 and 1 to the power 1, they are same. Now, if we have same basis, so if the bases are same, powers are to be equated. So from this, if we equate the powers, then we get 0 equals 1. We know that this is something that is absurd. This is not correct. But why we are getting it? Mathematically, it is correct. Now let us take an example how we have equated it. Suppose if someone wants to calculate the value of x here, right? And it is equated to, let us say, 16. All right. So I can express 16 as 2 to the power 4, right? 2 into 2 into 2 is 8. And again, when you multiply it with 2, you will be getting 16. So now if the bases are same, then the powers are to be equated. So we say that x equals 4. This is just an example. We did the same here. Now, sir, why we are getting 0 equals 1? So this is a question. And this question is genuine question, but why we are getting this? So let us try to have this analyzed. The statement itself is incorrect. When the bases are same, the powers are to be equated. This is not applicable for 1. Let us have a look here. Suppose if we are given with a to the power m and here we have a to the power n, they are equal. The bases are same, right? Then the powers are to be equated. Then we say that m should be equals to n. But I just wanted to explain this why we have 1 to the power 0 equals 1 to the power 1 and they are not 0 does not equal to 1, right? We can also have a case in which 1 to the power 64, which is equals to 1. So we can equate 1 to the power 64 and 1 to the power 0, and then we say that 0 equals 64. So that is also not correct. We have taken one such case here, right? Let us jump to a detailed explanation of this. I have shifted this a to the power n in the denominator, and the RHS will be 1. Now, according to the rules of exponents, a to the power m divided by a to the power n should be a to the power m minus n equals 1. Now, what I'll do, I'll take a log on both the side. It will log a to the power m minus n. It is log base 10 basically. So log base 10 1. Log base 10 1 means 0. See, I'll explain this as many of you are new to logarithms. Log 2 base 2 and 4 represents what? What power we should raise to 2 so that we'll get the answer as 4. That is what the representation of logarithm mean. All right. So the answer to this will be 2. Obviously, if you raise 2 to the power 2, you'll get 4. Let us consider one more example. What power of 2 you should raise so that you will get the answer as 8? So the answer to this is 3. Obviously, 2 to the power 3 is 8, right? So this is how you calculate logarithm of something. Now here, when nothing is mentioned as bases, these are the bases. So that means we have 10 as a base, right? So if we have log 10, 10 is the base, right? And we have 1 here. So what power of 10 you should raise so that you will have 1 as the answer? So I told you that anything raised to power 0 is 1. So 10 to the power 0 is 1. That means the answer to this will be 0. So log 1 comes out to be 0, right? Log 1 is 0. That means we can say that logarithm of a to the power m minus n equals 0, right? Now we have log a to the power p. This can be written like this, p log a. You can have b also, right? So using this rule, I am representing this situation. It is m minus n into logarithm of a equals 0. Now see, this is an equation, people, right? M minus n into logarithm of a equals 0. In order to have this equation as 0, either I can have log a as 0. Any one of them, if suppose they come out to be 0, right? Then the equation will become 0, right? Are you able to follow? Either this can be 0, either this can be 0, right? So if this particular thing is 0, that means m equals n. That is what we usually do, right? 2 to the power x equals 16, so x will be 4, right? The example that we have calculated. This is what we usually do, right? Because this 16 can be represented as 2 to the power 4, right? But if suppose m and n, they are not equal, right? If log a is 0, so here, what is the possible value of a that I should have? The possible value of a should be 1. So if I'll have a as 1, so this term will become 0. If this term will become 0, then this term need not be 0, right? So logarithm of a, if suppose it comes out to be 0, then no need to have m minus n as 0, because the thing is that the entire equation is getting 0. So m minus n, it is not necessary that it should be 0, right? So in this case, a should be 1, so it is not applicable for a equals 1. I hope you people are able to follow this. So this is the explanation, people. Thank you so much.